Why do TurboClean elements perform better than net-wrapped or full-fit elements? It all comes down to reduced bypass flow. What's bypass flow? Let's look at an installation of membrane elements. Spiral wound elements are installed in pressure vessels at a plant or facility. The feed solution is then pumped into the pressure vessels from one end and across the membrane surface. The fluid that passes through the membrane, known as permeate, spirals through the element and is collected in the center tube, also called the permeate tube. The retentate, or concentrate, that's rejected by the membrane passes through to the other end of the housing. That's where most explanations of spiral wound membranes end. Standard membrane elements have a fiberglass outer wrap and a rubber brine seal at the feed end of the element. The purpose of the brine seal is to prevent the feed from flowing around the outside of the element. While this type of element works wonderfully for most water purification and wastewater applications, for sensitive applications, such as those found in food and dairy, beverage, pharmaceutical, and dialysis, the brine seal creates a problem. This is because there's a stagnant area behind the brine seal where the water does not flow, creating ideal conditions for microbial growth. In these more sensitive applications, sanitary spiral elements are used. Sanitary elements don't have brine seals because some bypass flow is necessary to avoid stagnant areas where biological activity can grow. Let's return to our question from the beginning. What is bypass flow? Bypass flow is the feed that flows around the outside of the membrane element. Bypass flow is typically ignored in explanations about spiral wound membranes because it's wasted energy. Though some bypass flow is required, the amount of energy used to pump that flow is wasted. You encounter it both in operation and cleaning, which results in less effective production, as well as less effective cleaning. Bypass flow lowers cross-flow velocity across the membrane surface, leading to a greater concentration polarization and higher likelihood of fouling or scaling. The higher the cross-flow velocity across the surface, the more efficient the operation and more efficient cleaning. In short, you want as much of the feed going across the membrane surface as possible for higher productivity. TurboClean elements are manufactured to a precise diameter that reduces bypass flow by 60% or more when compared against conventional full-fit, net-wrapped, or caged membrane elements. The patented hard shell design provides many game-changing benefits as a result of reduced bypass. In process applications such as dairy, systems are cleaned daily. That translates to a lot of flushing every day. When an operation ends, the process must be flushed prior to cleaning. Cleaning fluids must then be flushed in each step of the cleaning cycle. On a daily basis, most producers flush their system at least 5 times. This wastes water and may lead to increased sewage costs. Because TurboClean elements have less bypass flow, more of the water is forced across the membrane surface, resulting in faster flushout. Water savings of 35% has been recorded in a rinse-out comparison following operation on 18% skim milk. Imagine if 35% of your water usage could be saved every day. Using TurboClean elements in your operations is another step toward meeting sustainability goals and working to create a cleaner world. TurboClean sanitary elements offer the lowest bypass flow of any sanitary element in a superior design. They are available for all membrane types, have a rugged and durable design, conform to 3A and USDA sanitary standards, use FDA-compliant materials, comply with European food regulations for plastics, are halal and kosher certified. TurboClean elements, game-changing benefits. The smart choice for processors of sanitary streams.